I want to talk about, like he said in the introduction, a real Canadian-German project that is ongoing right now. So first of all, I want to introduce the company I'm from. Basically, we are a subsidiary of the Schottel group. The Schottel group comes from ship thrusters, basically, and they decided some years ago that they want to invest in a new technology, and then they founded Schottel Hydro, and Schottel Hydro is basically just looking into tidal energy markets and how the technique for that can be applied and engineered. So basically Schottel Hydro is based on 3 columns. The first column represents our SIT systems. It's basically just a tidal turbine. Compared to other tidal turbines developer, we have smaller turbines. So the turbines that we plan to install in the Bay of Fundy have a diameter of 4 meters. That's very small compared to other developers. Then the second column is basically a tidal platform. I will come to that later because that's actually the project that we're having right now in Canada. And the third column is component supply. So we basically also do just engineer the hubs for pitching tidal turbines from other companies. So that's basically the project we're doing with our subsidiary in Canada, BlackRock Tidal Power. It's actually based in Halifax as well, because we are looking into the Bay of Fundy, and I have a short video. Yeah, there it is. Introducing to you the project that we're having.
Although people have talked about tidal power for over a century, they've never really made it work. It's a really important part of the renewable mix because you can't say when the sun's going to shine, you can't say when the wind's going to blow. With tidal power, we have predictability. We hope to be the first to get this cost competitive with the other renewables. Because if we can solve it here, it can work elsewhere.
In 2014, BlackRock Tidal Power was approved to install a tidal energy device in the Bay of Fundy. Soon after, I came over from our parent company Schottel Hydro to grow our amazing Canadian team.
The people who joined the team joined it because they were excited about this kind of frontier engineering that we were doing.
I'm the project manager, fabrication manager,
the office manager,
the integration manager,
compliance manager,
financial manager.
I made that title up. Yeah.
This is my hometown. It's a dream job for me.
The risk is very high because if we don't succeed, I have to move back.
We are at a really exciting stage of tidal development. The time for invention is over now. We are just at the doorstep to get from prototypes to commercial demonstration.
We have a lot of thrust that pulls the Triton downwards.
We have to do our homework now, right?
There's no time we have a plan that's written once. Everything is reviewed and rewritten and revised, looked at by third parties. For instance, the cross arms the turbines sit on were foil-shaped. This is going to be really expensive to make. So we changed that to a square shape, so we went from something that was going to be complex and costly to manufacture to something that was going to be simple and less costly. If we're going to make mistakes, we want to make them now on the whiteboard. We don't want to make them out there in the water. We're not looking at being cost-effective on Unit 15 or 16. Our company is focused on making this cost-effective at Unit 1 or the very latest Unit 2.
The technology is new, but it isn't new. And it's more that we have put these things together in a new way.
A tidal turbine is basically nothing else than a propulsion system, and Schottel has 65 years experience with propulsion systems. Seawater, cold water, high current speeds. So we do not worry at all about our turbines.
We have these pontoons that pivot, so they'll start in horizontal, then they go to vertical. That is based on a system that is being used by a ship in California for almost 70 years.
We have 40 small turbines instead of one big turbine. The smaller turbines are a lot more cost-effective to manufacture. If a turbine fails, we lose 2.5% of our generating capacity. If you have one turbine and one turbine fails, you lose 100%. We have the ability to do our maintenance on station. Put it into maintenance position, swap out a turbine, and an hour later have the thing back in the water generating power. That's a real differentiator between us and a lot of the other technologies. We're starting to cut steel now, and so we're starting to see the reality come to fruition. We are being driven to use local suppliers, local technologies, local people, because that's going to help us keep not only our capital costs down, but our operational costs as well.
I find that people are very excited about what tidal power can do. The words that come up most often from people is that it makes sense. You know, this project makes sense, tidal power makes sense. Nova Scotia is at the point where we can actually demonstrate commercial technology. We have the opportunity to be experts on something that is going to happen globally. Once we've proven that this technology is safe, it's reliable, we'll be able to expand into the rest of the Bay of Fundy and then onto the world.
So basically, that was the best introduction you could get to the whole project and what's going on right now. And it's also the first time we show that video because it's very, very new. So yeah, to look into more technical details of the whole project in a slow motion kinda. That's basically a project that we're working together with the Canadians. It's a tidal platform, consists of the spar buoys, it's the upper floating parts, then the tether arms are connected to the pivot, and then it's pivoting around and adjusting itself to the tidal flow. And so we can harvest the most energy out of the actual tidal flow. Yeah, the rated speed is 3.0 meters per second, since you all know that basically in Halifax, Nova Scotia, they are the highest tides in the world. The flow is really high as well. That makes that machine really efficient. And we are in the construction phase right now. So like you saw, there's already steel being cut and developments going on. And the installation should take place in summer 2017, so next year. So that's the Bay of Fundy, where the actual installation site is. And the blue circle that you see, that's the site where we want to install the Triton. The other sites are for other companies reserved. So, and because such a project needs as well all the data you can get from this place where you want to install it. We had 2 ADCPs in the water. ADCPs measuring the water speed over a different level of the sea surface. And what you basically see, we had it deployed in 2 different points. The red dots are where the ADCPs are deployed. And we had the post-processing performed by GI Garrett Hassan in Bristol. But basically what the outcome was, what we have here on the right-hand side, is the distribution of the flow velocities over the whole tide. For flood, that's the green one, and for ebb, it's the cyan one. And what's basically see that the flood is stronger than the ebb. And so we are gonna harvesting more energy during flood times. What we also did from this data, we were analyzing the data to get a correct flow profile over the sea height. So we know exactly then for later on processing how much energy does what turbine generates and how the forces are distributed over the platform. What else did we do with the data? So we also measured waves, of course, and we measured wind directions, and basically we used it all to derive our load cases. The design of the Triton is this time totally based on the Bay of Fundy because we had there the most data. So the whole structure is based on data we collected there, and we used the data to derive ultimate load cases that the platform has to survive and the fatigue load cases that the platform have to derive. And basically we created, it's a combination out of flow speed and waves that we are looking into. And we had a lot of data to analyze and then put it so together that we knew in what years we see kind of what waves, so we can make the structure stable enough. We also not only working with our subsidiary in Canada together, also we are using engineering supply from there. That's basically a base Canada company as well. There's DSA. They having a tool that we can input all our environmental data, like with waves and flows, and generating the structure in it as a multi-body simulation, and then see exactly at what points what forces act on the structure and how stiff the structure has to be and development has to be. And very important for us is as well how behaves the structure. Is it dangerous in sea stays to get too close to the structures? How do the ships have to, in what radius do they have to stay away so they won't be hit? We have also, that's now kind of the future plans we do, as soon as the Tidal platform is installed, we will have sensors on the platform as well. So, and we also will look into projects, in research projects with the Dalhousie University, doing data processing then of all the sensors we have on the platform, and looking also into acoustic modeling, because always a topic is as well how do the mammals behave around the platform, how are the fish affected by it, and so on. So basically we're gonna have on the platform 2 hydrophone, sonars, video cameras, also acoustic flow measurements and strain gaugers to see how the platform actually behaves, and if we are with what we expected in the calculation, if we see that in real life as well. So that's where we actually gonna place ADCPs and ADVs as well. ADVs measure the turbulence in the flow, and ADCPs the flow speed over a certain range. So we will have a lot of data that we're gonna process, and we are not totally sure how we're gonna handle that yet. But we're in progress also with our Canadian colleagues to develop the system behind it. Thanks for your attention.
Thank you. I would like you to stay on stage and Camilla to join us. And over in Halifax, if Hannes, you and Sherry could join the stage. But do you have an immediate question for Sarah in Halifax?
Yes, there is one immediate question.
Thomas Rappenberg. I'm here with Computer Science at Dalhousie University. There's a lot of concern in Nova Scotia and discussions about the impact on the environment, especially in the fishing industry. And I'm wondering, what you're planning to monitor this. I think some contribution to this discussion would be really good in order to deploy this on a much larger scale.
Sarah.
Yes, we've heard a lot about the concerns that we're having, especially with the fisheries. I think the studies going on right now are very good, and we really try to make sure that with our first platform, when we install it, make sure that we get enough data to kind of say that we're not affecting the life of the animals around the structure a lot.
Thank you. There's another question, Hannes?
Yes, one more.
Hi, Sue Malloy with BlackRock Tidal Power. I work with Sarah as well. Just to clarify on the fisheries issue, we have been building relationships with researchers here in Nova Scotia. One example is Stan Matwin. We've been working on ways to actually manage all the data that comes off of these machines through data management systems. And we're working with OERA, and we're building on the work that's been done. So there's a lot of work has been done by OERA, by FORCE, and local researchers from Acadia and DAL over the years. And we are contributing to that by collaborating. And then we're also, on our platform, we have a fairly unique opportunity because the machine will be pivoted to the surface every 6 months. So that allows us to put instrumentation on the system that would be able to be monitored and removed and fixed, and we'd be able to put other instrumentation that maybe we don't see now as necessary, but in 6 months or 2 years we might say, okay, now we need this kind of instrumentation. One of the goals that kind of fits with themes like Doug has mentioned earlier, something I personally see, is there's a real opportunity with these tidal turbines in spaces like the Bay of Fundy and other places. If we have a lot of turbines and we have a lot of instrumentation on that, then we can start to really build a strong data set, 365 days a year, 24 hours a day, streaming data on the ocean. So that will actually help us to inform some of this global warming concerns.
Thank you. And did we just see you on the video, huh? Okay, Hannes.
Alex, we have another question here, so I don't know if you want to take it. I'll leave that up to you.
Yeah, but I would like to take Sherry and Doug already take a place at the podium, because we have another 10 minutes that we can address all of the 4 speakers we had until now, before we have a break. Some coffee, tea, cookies, fresh air. Okay, but let's take the other question for Sarah.
Hi, Desiree Stockerman from Ocean Sonics. Just
Hi.
a quick brief. We develop hydrophones, smart hydrophones, and there are actually several of them already on the other platform in the Bay of Fundy. And I just wanted to ask the speaker, I know you mentioned about when the platform is in, that you'll have all your sensors on board, and that's great, but I think, and I'm not against the fisheries here, because of course my hydrophones are being used with the platform right now, but we did a lot of work before the platform went in with the consortium to make sure our products worked with their turbine, and I'm just wondering what sort of work you're doing before you install the platform.
Would you take that question, Sarah?
Are you relating only to the hydrophones or to all the other sensors as well?
Well, all the sensors are integrated together to work together. So, yeah, all your sensors.
Okay.
On the environmental side.
Yeah, so basically, that's mostly done in, yeah. Good question. We had like the flow measurements, ADCPs already inside. And so that is all working together. We are putting up our plan where they have to be placed and working with universities and talking to people and people to force as well, where we need to place them, that we get the most data out of it.
Thank you. And I